What we're doing today is we're going to be graphing a linear equation that has two variables. There's some words that I like to review. First of all, standard form. If you notice in that box, we have ax plus by equals c. We know that a, b, and c are coefficients, are real numbers. And we notice that the x and the y are on the left side. That is considered to be in standard form. And when you graph this equation, it's going to be linear. So what I'm going to do is, for example 1, we have the linear equation 2x plus y equals 5. I'm going to go ahead and create a table. And we have x and we have y. And what we're going to do is we're going to generate points based on the equation that's in standard form. So I'm going to let x equal 0. And you notice we don't know what y is. So what we're going to have to do is we're going to have to substitute x equals 0 into the equation. And this equation is 2x plus y equals 5. So we notice that we have 2x, so it's going to be 2 times 0 plus y equals 5. And the product of 2 and 0 is 0. So we have 0 plus y equals 5. Therefore, y is equal to 5. Now you can choose any number besides 0, and I'm going to choose 1. So the next step that we're going to do is we're going to find the value of y when x equals 1. So just like we did before, we're going to substitute for x, we're going to substitute x equals 1. So we have 2 times 1 plus y is equal to 5. And we know that 2 times 1 is 2 plus y is equal to 5. So we're going to go ahead and subtract 2. So y equals 3. What we're going to do now is we're going to go ahead and graph those 2 points. And we notice that we have a Cartesian plane. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. This right here is the origin. And so we're going to start at 0, go up 5. And then we're going to graph the next point, which is going to be 1. We start at the origin, go to the right 1, and then go up 3. Now you notice that the distance from this point to this point, from this point to this point in the y is 2, and the change is 1 over the x. That is called slope. So what I'm going to do is I'm going to repeat the process to find, repeat the process of going down 2 and going over 1. That's slope. Going down 2, going over 1. Going down 2 and going 1 to the right. That is slope. And then what I'm going to do is I'm going to go ahead and connect the points. Now the original points were 0, 5, and 1, 3. And just like I told you before, we use the slope to come up with the other points that are on this line. We're going to continue graphing with example 2. Just like example 1, we're going to go ahead and graph this linear equation. And we notice that it's in standard form. And you might be asking, how do I know it's in standard form? Well, the x and the y are going to be on one side of the equation. In this case, it's on the left side. What I'm going to do is I'm going to go ahead and create a table. And I'm going to go ahead and generate these points. So I'm going to go ahead and start with x equals 0. So I have x equals 0. And what I'm going to do is I'm going to go ahead and substitute into the equation negative 5x plus 3y is equal to 15. So x is going to replace with 5. So we have negative 5. I meant to say 0. X is 0. So x is going to be replaced with 0. So we have 0 plus 3y equals 15. So we have negative 5 times 0 is 0 plus 3y is equal to 15. 0 plus 3y gives you 3y equals 15. Since we're multiplying, we're going to go ahead and divide by 3. So y equals 5. So we have 0, 5. Like I said before in example 1, you can choose any number. We're going to go ahead and choose 3. And we're going to go ahead and say x equals 3. So we're going to substitute. For x, we're going to substitute 3. So we have negative 5 times 3 plus 3y equals 15. Once again, we have our standard form of equation. It's going to be negative 5x plus 3y is equal to 15. I'm choosing to use x equal 3. And so what I'm going to do is I'm going to substitute for x. I'm going to substitute 3. We're going to go ahead and multiply these two. And we have negative 5 times 3 is negative 15 plus 3y is equal to 15. And since we're solving for y, we're going to add 15 to both sides. And we have 3y equals 30. And so what we're going to do is we're going to divide both sides by 3, so y equals 10. So our point is going to be 3, 10. So our first order pair is 0, 5, and our next order pair is 3, 10. So we're going to go ahead and start at the origin. Once again, this is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. This is the origin. We're going to start at the origin and go up 5. So there's our point. And the next point is 3, 10. So we're going to start at the origin, go to the right 3, and then go up 10 units. Now, what I'm going to do is I'm going to go ahead and draw what I told you before was a slope. So we have 1, 2, 3, 4, 5. So it's 5 to 1, 2, 3. And you notice this slope is going to be increasing. So what I'm going to do is I'm going to go down 5. 1, 2, 3, 4, 5. 1, 2, 3. And slope, once again, is defined by the rate of change from one point to the next point. So like I said, there's 1, 2, 3, 4, 5. 1, 2, 3. Then I'm going to repeat the process. 1, 2, 3, 4, 5. 1, 2, 3. And then what I'm going to do is I'm going to go ahead and connect the points. And you notice it's linear. It is linear and it's increasing. The slope is increasing. So the graph is linear and it's in a line. And we know that the slope is increasing. And the slope, once again, is the rate of change from one point to the next. We're going to go ahead and do example 3. And you notice what I'm going to go ahead and do is I'm going to go ahead and make a table. And I'm going to graph this equation. And once again, you can use any x value that you like to choose. So what I'm going to do is I'm going to go ahead and choose 0. And I'm going to substitute the value of 0 for x. So I have y equals negative 1/3 x plus 2. So like I said, I'm going to substitute the value of 0 for x, and we can evaluate that it's going to be 2, since negative 1/3 times 0 is 0, and we're left with y equals 2. Since our fraction is 1/3, we would like to use a number that's divisible by 3, and we know that 3 is divisible by 3. So we have y is equal to negative 1/3 times 3, and since it's a fraction, I'm going to say 3 over 1, that's improper, plus 2. We have negative 1 times 3, which is negative 3, divided by 3 times 1, which is 3, plus 2. And we have negative 3 divided by 3, which is negative 1, plus 2, which is, it will be negative 1 plus 2 is going to be 1. So we have 3, 1. So our order pairs are 0, 2, 0, 2. And our next order pair will be 3. We start at the origin, 3, 1. Once again, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And you notice this slope is going to be decreasing. We like to read it from left to right. It's decreasing. It goes down 1 unit and it goes over 1, 2, 3. And you can repeat this process if you want to graph it. It goes down 1 unit over 1, 2, 3. Goes down 1 unit over 1, 2, 3. Or you can go in the other direction and go up 1 unit and go over 1, 2, 3. We have enough points to create a straight line since we know that this will be linear. So this is a linear equation. The slope is negative since it's decreasing. Is the equation, or that is a graph for y equals negative 1/3 x plus 2. Now for example 4, we have y equals negative 2. And you notice there is no x. There is the value of x is not included in this equation. So it isn't a typo. It is y equals negative 2. So we're going to go ahead and we're going to create a graph y equals negative 2. So we're going to go ahead and write negative 2 for y. And just like I said in class, you can use any x value. So I'm going to go ahead and use 0, and I'm going to use 4. So we have 0, negative 2, and we have 4, negative 2. We have 2 points, so we can go ahead and graph this line. And you notice this line, or this equation, will be horizontal. It will also have a 0. It will have a 0 slope. And that is the end of our lesson for today.